More than 60 years after Hanford embarked on a secret government mission that provided the plutonium for the world's first atomic weapons, the Hanford site is now in the process of making history of a completely different sort. The Department of Energy Office of River Protection is preparing to treat millions of gallons of radioactive liquid waste at what will be the world's largest, most complex nuclear waste treatment facility. Once up and running, the waste treatment plant, also known as the vitrification or VIT plant, will immobilize Hanford's radioactive liquid waste into thousands of glass logs for safe, long-term storage.
But how did we get here? Where did the waste come from? And why is this facility being built in the first place? To answer these questions, we must travel back in time.
In 1945, scientists and engineers at Hanford's B reactor created the world's first weapons-grade plutonium used in the atomic bomb dropped on Nagasaki, Japan to end World War II. In the years after the war, Hanford was expanded to include a total of 9 nuclear reactors and 5 plutonium processing plants, all using different chemical processes. These facilities produced much of the material needed to build the U.S. nuclear weapons arsenal during the Cold War. When the final nuclear reactor was shut down in 1987, a deadly legacy remained. Millions of gallons of chemical and radioactive waste, byproducts of the decades Hanford was actively producing plutonium. 56 million gallons of that waste is currently stored in 177 underground tanks, some of which are known to have leaked, threatening the groundwater and the nearby Columbia River.
The waste stored in these tanks right behind me is the focus of our nation's largest environmental cleanup effort. Buried under 10 feet of soil and gravel and holding up to 1 million gallons of waste, each tank is only accessible through a series of pipes called risers, most of which range in size from just a few inches to just over a foot in diameter.
The first step in this complex process is transferring waste from old single-shell tanks to newer double-shell tanks to prevent further leaks and contamination of the soil and groundwater below. All of the pumpable liquids have been transferred, and work now focuses on transferring the non-pumpable liquids. Workers must lower tools through the risers to remotely scrape, scour, rake, and push the waste toward a centralized pump. Because the tank waste varies from sludges to salt cakes and concrete-like solids, different methods are used to remove the waste from the tank. Most recently, a specially designed robotic arm known as the Mobile Arm Retrieval System has been implemented to move most of the waste forms. The robotic arm is mounted on a mast installed in the center of the tank. Operators use a series of cameras and controls to extend the arm around the tank and safely remove the waste. But transferring waste from one set of tanks to another is only a temporary solution. The waste will be hazardous for thousands of years, making a permanent solution necessary.
To solve this problem, the DOE is building an integrated system to treat and immobilize the waste. The waste treatment plant will use a process known as vitrification to immobilize the waste in solid glass for safe, long-term storage. Vitrification is a proven technology, currently in use in the United States and Europe, though never on a scale as large as Hanford's VIT plant or with waste as chemically complex.
The vitrification process will begin with the transfer of tank waste to the 65-acre VIT plant through underground pipes. Hanford engineers are currently focused on building the infrastructure needed to consistently feed the VIT plant large batches of tank waste. The waste is first pumped into the pre-treatment facility, which spans 1.5 football fields and reaches 12 stories high. Here, the high-level waste is separated out from the low-activity waste, and the 2 waste streams are then sent to the appropriate vitrification facilities. The high-level waste arrives at the high-level vitrification facility. The waste is then mixed with glass-forming materials in 90-ton melters, heated to 2100 degrees and poured into 14-foot tall stainless steel containers. This facility will be capable of producing 6 tons of glass per day, or 1.5 containers of waste. A similar process occurs in the low-activity waste vitrification facility, which will treat roughly 90% of the tank waste. In this facility, larger 300-ton melters will heat the waste.
Due to the large amount of low-activity waste, the department is exploring additional treatment opportunities that may shorten the waste treatment mission. Plans to start processing the low-activity waste prior to full operations are also being examined. This would provide valuable experience for plant operators before the facility begins processing the higher hazard waste. It would also jumpstart the process of getting waste out of the tanks and into a safer form.
Throughout the vitrification process, samples will be sent to the analytical laboratory to ensure the final glass product meets strict standards. The laboratory, which includes 14 hot cells, will analyze 10,000 samples annually. The VIT plant, which includes 4 nuclear facilities, 20 support facilities, and extensive underground facilities, is a monumental design and construction challenge. The project requires more than 260,000 cubic yards of concrete, enough to fill nearly 75 Olympic-sized swimming pools, plus another 40,000 tons of structural steel and more than 170 miles of piping. Design of the facility will be complete in 2013, with construction finishing in 2016. After thorough testing, the plant will begin processing tank waste. After the glass logs are produced, they are destined for storage facilities. The low-activity waste containers will be stored at the Hanford site. High-activity waste containers will be temporarily stored on the site in an interim storage facility and then moved to a future National Geological Repository.
Our mission at the Office of River Protection is to remove the threat posed by Hanford's radioactive liquid tank waste. To accomplish this mission, ORP will use an integrated one-system approach to manage the safe storage, retrieval, and delivery of tank waste to the facilities we are building to immobilize it. This one-system approach keeps us focused on our whole mission and how best to accomplish it.
As the cornerstone of cleanup, the one-system approach is integral to Hanford's future. The Office of River Protection is committed to implementing its mission safely and reducing the risks posed by the tank waste to all of us and the environment.